A planet 120 light years away may have just low-key breathed at us through starlight. Not a spaceship, not a radio signal, not some fake alien clip on your feed, an actual world with chemistry so suspicious that scientists had to stop and ask the one question humans have been ducking forever. Are we finally looking at life? If this signal is real, then the universe didn't wait for us to be ready. It may have been alive the whole time, just sitting out there in the dark, quietly leaking evidence into space while we were down here arguing about whether we were special. So, what did James Webb actually find? Why are scientists freaking out, and why are they still refusing to say the words "we found aliens"? That's where this gets really good. The planet is called K218b, and no, it's not some Earth clone with nice beaches and a chill little blue sky. This thing is way stranger than that. It orbits a small red dwarf star in Leo around 120 light years from Earth, which in cosmic terms is honestly kind of close. And size-wise, this planet is a unit. It's around 2.6 times wider than Earth and about 8.6 times more massive. So you're not looking at a second Earth. You're looking at one of those weird in-between worlds our own solar system doesn't even have. Too big to be a normal rocky planet, too small to be a full gas giant. Basically, it sits in that suspiciously interesting zone where planetary science starts getting spicy. That's why scientists started calling it a Hycean world candidate. And yeah, that sounds like a made-up word from a sci-fi wiki, but it matters a lot. Hycean comes from hydrogen and ocean. In simple terms, picture a world with a thick hydrogen-rich atmosphere and maybe a giant global ocean underneath. Not Earth 2.0, not Neptune light, something weirder, and that matters because for years, the search for life kind of assumed we needed to find planets that looked emotionally familiar to us. Rocky, temperate, surface water, nice atmosphere, basically Earth in a different outfit. But K218b is forcing scientists to admit something kind of humbling. Life may not care what looks normal to us. It may be perfectly fine under a sky we'd hate, on a planet we'd never want to visit. So how did this world go from random exoplanet to main character of astrobiology? That took a while. Back in 2015, Kepler found it through the transit method. The planet passed in front of its star. The starlight dipped a tiny bit, and boom, there it was. Then Spitzer helped confirm that K218b sits in the habitable zone of its star, which means the temperature range could allow liquid water. That alone got people interested. Then Hubble stepped in and found water vapor in the atmosphere. That pushed the planet from maybe interesting to, okay, now you have my attention, because water gets you on the list. Water doesn't prove life, but it definitely gets you invited to the conversation. But let's be real. Water vapor alone doesn't break the internet. Mars had water. Europa probably has water. Even dead worlds can have water. The real shift came when James Webb looked at K218b and started doing what it does best, reading chemistry through light with almost unfair precision. And that's the part you need to picture clearly, because Webb is not taking some cute postcard image of this planet. It can't. K218b is too far away and too close to its star for that. What Webb sees is the star's light passing through the planet's atmosphere during a transit. Different molecules absorb different wavelengths, so when that light reaches us, it carries chemical fingerprints. Think of it like the atmosphere leaving little receipts in the starlight, and that's the moment the story stops being normal. Because Webb didn't just see one thing. It picked up methane, it picked up carbon dioxide, it reinforced the case for water vapor. Already that's wild enough because now you're looking at a thick atmosphere with a chemistry set that does not scream boring. But then came the signal that made everybody sit up straight, dimethyl sulfide, or at least a signal consistent with dimethyl sulfide or its close cousin, dimethyl disulfide. And on Earth, dimethyl sulfide is not some random gas doing side quests in the atmosphere. It's tied mostly to life, especially marine microbes and phytoplankton. If you've ever smelled that sharp, salty, alive scent near the ocean, part of that smell comes from dimethyl sulfide, which means this story got weird fast. Because what do you do when the smell of biology may be sitting in the sky of a planet 120 light years away? This is where your brain wants to sprint straight into aliens. Scientists do not get to do that. Their job is way more annoying and honestly, way more respectable. They have to slow down, kill the hype, and ask the rude question, could anything else make this gas? Because if you announce life on another world and you're wrong, that's not a cute little mistake. That is one of the biggest scientific cell phones of all time. So instead of celebrating, they started trying to wreck their own result. And that's exactly why this story matters. Most biosignatures are messy. Methane can come from life, but geology can make it too. Oxygen sounds amazing until you remember non-biological processes can build that up in some cases. Phosphine looked exciting on Venus until the whole thing got dragged into the mud by reanalysis and doubt. But dimethyl sulfide stands out because scientists do not know of any normal abiotic process that makes a lot of it efficiently in a planetary atmosphere. On top of that, it doesn't last long. Sunlight breaks it down. Atmospheric chemistry tears it apart. So if you see it, something has to keep making it. That detail is huge. This is not one of those gases that can show up once, hang around forever, and trick everyone. If the signal is real, something active has to replenish it. Something has to keep cycling chemistry into the atmosphere over and over again. Now ask yourself, how interesting does a planet get when its atmosphere may be getting constantly refreshed by a molecule that on Earth life makes? Very interesting. Like, cancel your afternoon interesting. And then came the number that made headlines go feral, 99.7%. That number comes from the statistical confidence of the signal, around 3 sigma. In normal person language, that sounds basically done. 99.7% feels like somebody should already be designing the Alien documentary poster, but science is brutal about this stuff, especially when the claim is huge. 3 sigma does not mean confirmed. It means exciting. It means serious. It means not easy to dismiss, but it does not mean lock it in forever. For a discovery this massive, scientists want 5 sigma. That's the gold standard. That's the level where random noise becomes absurdly unlikely. That's the threshold used for things like the Higgs boson and gravitational waves. So no, James Webb has not confirmed alien life. Let's kill that bad headline right now. What it may have found is one of the strongest biosignature candidates we've ever seen on a habitable zone planet. And honestly, that's already insane. You do not need to fake the story. The real story is strong enough. And here's what makes it stronger. The case for K218b doesn't hang on one molecule floating out there by itself like some lonely chemistry miracle. It's the whole pattern that feels off in the most interesting way. Methane plus carbon dioxide in a hydrogen-rich atmosphere, water vapor, the possible sulfur signal, the possible lack of ammonia in places where some models might expect it. In other words, the atmosphere may not just contain one suspicious gas. It may be showing a broader chemical imbalance, a world whose sky refuses to settle into the boring dead answer. That idea matters a lot. Dead planets drift toward balance. Living worlds keep ruining that balance. Life eats, exhales, reacts, converts, and recycles. It keeps a planet chemically restless. Earth does this constantly. Our atmosphere only feels normal because we grew up in it. To an alien astronomer, Earth might look chemically ridiculous, oxygen hanging around in huge amounts with other gases that should have reacted away a long time ago. That would scream activity. That would scream metabolism. K218b may be speaking a different dialect, but it might be using the same basic language. Now, before you start calling this planet phytoplankton prime, there's a problem. We still don't know exactly what K218b looks like down below. And yeah, that changes everything. The fun version is the true Hycean version. Thick hydrogen atmosphere up top, deep global ocean below, maybe microbes doing their thing in the water and pumping gases upward into the sky. That's the version that makes this planet feel like a serious alien ocean world. But there's a less fun version too. Some models suggest K218b could be more like a mini-Neptune, no real nice surface, no clean ocean sitting there waiting for a documentary voiceover, just deep crushing layers of atmosphere, fluid, and high pressure ice. In that picture, the chemistry still matters, but the whole life story gets harder to call. So which one is it? That's the fight right now. Spectroscopy can tell you a lot, but it can't just hand you a postcard from the lower atmosphere. Scientists still have to model the planet's structure, temperature, clouds, chemistry, pressure, and how all those things mess with the signal. And that's why people in the field are excited and cautious at the same time. They're not being boring, they're being disciplined. The universe loves edge cases. It loves weird chemistry. It loves making us look stupid when we get overconfident. So researchers are testing every alternative they can think of. Could strange non-biological chemistry make dimethyl sulfide in a hydrogen-rich atmosphere? In principle, maybe tiny amounts. Lab experiments suggest some abiotic pathways can create trace levels, but scaling those up to explain the possible abundance on K2-18b gets rough fast. You need special conditions stacked on special conditions, stacked on more special conditions. Could comets deliver it? People checked that too. Comets can contain dimethyl sulfide, but keeping enough of it in a planetary atmosphere would require absurd constant bombardment, and that should bring a whole bunch of other chemical baggage with it. So far, the atmospheric pattern doesn't really match that story either. That doesn't mean biology wins by default. It means biology starts looking simpler than the alternatives. And that is a very different kind of tension. The exciting version of this story is not that scientists found life and called it a day. The exciting version is that scientists keep trying to explain the signal away, and the life interpretation keeps refusing to leave the room. Also, you have to appreciate how stupidly impressive the method is. We are talking about measuring the chemistry of a world we cannot visit, cannot photograph directly, and cannot even separate cleanly from its star with normal vision. James Webb sits out at L2, cold, dark, and optimized for infrared, and from tiny dips in starlight it pulls out hints of methane, carbon dioxide, water vapor, and maybe a biosignature gas that is not normal telescope work, that is cosmic detective work, that is reading the weather, chemistry, and maybe even the biology of a world from a few wiggles in light. Like, be serious. That's insane. And it gets even crazier when you think about the timing. The light carrying this possible signal left K2-18b around the early 1900s. Back then, humans had barely figured out flight. No satellites, no moon landings, no Webb, no modern astrophysics flex. While that light crossed interstellar space, we went from fragile planes to giant infrared telescopes parked far beyond Earth. The message started traveling before we had the tools to understand it. The universe may have mailed the answer long before we learned how to open the envelope. That detail changes the vibe of the whole story, doesn't it? Because suddenly this isn't just about one planet. It's about how late we are to the conversation. K2-18b did not become interesting when James Webb launched. If life is there, it was there already, cycling gases through its atmosphere while humans were still inventing basic technology. And if that thought doesn't mess with you a little, I don't know what will. The universe may not be quiet. We may have just been too early and too under-equipped to hear anything. So what happens now? More observations, more transits, more chances to separate dimethyl sulfide from look-alike molecules, more modeling, more lab chemistry, more checks on the host star, more attempts to figure out whether this atmosphere really points to biology or whether the universe is pulling some insane chemistry trick we haven't fully understood yet. If the signal keeps showing up and pushes toward 5 sigma, this whole conversation changes. At that point, K2-18b stops being a cool maybe and starts becoming the first serious case that life has left a detectable fingerprint on another world. And if that happens, this planet will do more than answer one question. It'll blow up the whole search strategy. Because for decades, the dream was another Earth. Same size, same atmosphere, same kind of star, same basic setup, but K2-18b is reminding scientists that life might be easier to spot on stranger planets than on familiar ones. A hydrogen-rich atmosphere may amplify certain biosignature gases better than Earth's atmosphere ever could. Hycean worlds may be more common than true Earth twins, which means the first living planet we recognize may not look like home at all. It may look bigger, wetter, darker, weirder, and way more alien than people expected. That is such a good plot twist. Maybe we were searching for something emotionally comfortable when we should have been searching for something chemically obvious. Maybe the first world to crack the silence was never going to be Earth 2. Maybe it was always going to be a weird ocean wrapped in hydrogen under a foreign sky, just sitting there waiting for us to stop being so obsessed with ourselves. And that's why this story hits harder than a lot of people realize. This isn't just about whether K2-18b has microbes. It's about your whole idea of a living world getting stretched. It's about humanity moving out of the era where life beyond Earth felt like pure imagination and into the era where we can actually test for it, argue about it, model it, and maybe, if the data keeps getting stronger, measure it. So no, don't say James Webb definitely found aliens. That's lazy, but don't flatten this into some dry little science update either, because that's lazy too. What happened here is way more interesting than either extreme. Humanity may have just picked up the strongest atmospheric hint yet that a distant world is being actively shaped by life, not cities, not signals, not giant spaceships, but biology doing what biology always does, eating, reacting, exhaling, and changing a planet. And honestly, that may be the creepiest version of all, because once you really let that in, the stars stop feeling decorative. They stop being this pretty wallpaper over your life. Somewhere out there, maybe on K218b, an ocean may be full of alien microbes doing their own version of metabolism under a sky full of hydrogen, while that planet quietly vents its chemistry into space for anyone advanced enough to read it. No fanfare, no announcement, just life being life on a world that has probably been doing this for ages. K218b might turn out to be the first real crack in the silence. Or it might end up teaching us how brutally careful we have to be before saying we found life. Either way, you're living through the moment the question stopped being just philosophy and became something science can actually chase down. And that's the part I can't get over. James Webb may not have closed the case, but it may have found the first planet that made the case impossible to laugh off. So next time you look up, remember this: the universe may not be quiet at all. It may have been breathing the entire time, and we only just learned how to listen.